Loading data from a SQL database. This will be our final pandas use case. In this video, we are going to take a look at different data sources that are present and loading data from a SQL database. So let's head over to our notebook. As usual, we get the imports out of the way, and this time we are going to import SQLite 3 or SQLite 3 because that will be the database that we are going to use to load data in pandas. So far, we have only talked about reading data from CSV files. There's a pretty common way to store the data, but there are many others. Pandas can actually read data from HTML, JSON, SQL, and also Excel, HTF5, Stata, and a few other things. The crux of it being, if you can store it, pandas can load it. In this chapter, we'll talk about reading data from SQL databases. You can read data from a SQL database using the read_SQL function, and the read_SQL function will automatically convert SQL column names to data frame column names. Read_SQL takes two arguments, a select statement and a database connection object. This is great because it means you can read from any kind of SQL database. It doesn't matter if it is MySQL, SQLite, PostgreSQL, or something else. In this example, we read data from a SQLite database, but any other database would work the same way. So we do SQLite3.connect and we specify the database object. And then we pass the connection object that we did on our first line to the read_SQL function along with the select statement. If we take a look at this data frame, then we'll see that it has three columns: ID, date_time, and temp. And these are our corresponding columns on our database. And since we limited the number of rows to 3, we only see the 3 rows on our data frame. So the read_SQL doesn't automatically set the primary key for us. We will have to make it do that by adding the index_call argument that we have seen previously in the read_CSV as well. So if you have actually used read_CSV a lot, you may have seen that it has an index_call argument. This one behaves the same way. So this time we are going to read SQL, but we're also going to specify the index_call parameter and set it to ID, the name of the column that we want to assign as index. Done. And just like that, you'll be able to compare this output with the previous one, and you'll actually see that the ID column has been set as an index of this data frame. Now, if you want your data frame to be indexed by more than one column, that is possible too. You just have to pass a list of columns instead of a string. So in this case, all we are doing is passing a list of columns to the index_call parameter, and our data frame adapts itself to include a combination of the ID and the datetime column to be the index. Now that we have successfully loaded data from a SQL database, it is time to check out how to write data into a SQL database. Pandas has a write frame function which creates a database table from a data frame. Right now, this works only for SQLite databases. So let's use this to move our 2012 weather data into SQL. You'll notice that this function is in pandas.io.sql. There are a ton of useful functions for reading and writing various kinds of data in pd.io, and it's worth spending some time exploring them. As usual, I have embedded the link, the documentation link, in the notebook. So what we are going to do here is read our CSV from our weather data, connect to our SQL object, drop the table weather_2012 if it exists, and then finally use the to_SQL method this time to write our weather data frame into a SQLite table. Done. We can now read from the weather underscore 2012 table in test underscore db.sqlite, and we see that we get the same data back. So just as we read data in the previous bits of code, we initialized our connection objects in the test.db SQLite file that we already have in our data folder, and do a select star limited to 3 for fast retrieval and try looking at the data. And just as we have seen the weather data, we were actually able to retrieve the same data using SQL techniques. The nice thing about having your data stored in a SQL database is that you can do arbitrary SQL queries. So all of the EDA that we have been doing so far, we can actually condense that to SQL queries and start treating them as SQL implementations. This is cool, especially if you are more familiar with SQL. Here's an example of doing the same thing on our weather data set, where we want to sort by the weather column. So we connect to our database object, read from it, and we use the order by technique while passing our SQL query to our read underscore CSV function, and we can actually have data that is sorted by the weather column. If you have a PostgreSQL database or MySQL database, reading from it works exactly the same way as reading from a SQLite database. You can create a connection using the snippet mentioned here or the corresponding one for the MySQL implementation, and then do your regular read underscore CSV. To connect to a MySQL database, you will need a working MySQL or a PostgreSQL database with the correct localhost database name and all those connection parameters. I've actually embedded the code that will make it work once you have those databases up and running on your system. And that's it. That's the way you read data in pandas from SQL databases.